Welcome to Ceph News at 10. I'm John Schubeck, and this video is all about the Ceph NVMe over Fabrics demonstration. Let's get right to it. To set the stage for our demonstration, we need a little bit of a roadmap. The outermost shell in this group of constructs is called the gateway group, and it is established when we start our NVMe over Fabrics service instances. The first layer of what I would call the storage constructs is the subsystem, which is a logical group of NVMe resources. Within the subsystem is a listener, which is essentially the endpoint presented by two or more Ceph nodes where the NVMe service is running. Next is the namespace. In this diagram, we see namespaces 1 and 2. We can think of a namespace as a LUN or a volume, something the NVMe client will consume for storage operations. Finally, we have the controllers. Controllers are internal data movers, or storage engines. They are ephemeral, and the Ceph cluster spins them up and down as needed in response to NVMe client connections. With that as our baseline of understanding, let's get to the live demonstration. All of my work on the Ceph cluster side will be done using the Ceph dashboard browser experience, logging in as my admin privileged user. We see our dashboard homepage. The first thing we're going to do is create a Ceph pool, namely an RBD pool. Now, in theory, if we already had an RBD pool available, we could conceivably use it, but I don't think it's very good practice. We don't get the point of control or the level of granularity we might want, so I would recommend creating a separate RBD pool only for NVMe over Fabrics operations. So NVMe pool is being created. The next thing we will do is start our NVMe over Fabrics service. We will create a minimum of 2 service instances. There's no one right answer. We could do 2 instances, 3, or all 4, and 1 on each node in our cluster. We will select that NVMe pool that we created a minute ago. We could accept the group name of default, but in my case, I'm going to give it a named group name of, well, group 1. And finally, select 2 or more hosts to run the service on. So there's nodes 3 and 4, create the service. And we are back. As the old saying goes, all engines running. We have NVMe over TCP service running on nodes 3 and 4. From there, my block group NVMe over TCP property pages light up. I can navigate to gateways and see my service instances on nodes 3 and 4. We will now create a subsystem, and we will get a NVMe qualified name automatically, a maximum number of namespaces. We can accept those defaults or make the changes on our own. We can now expand our subsystem to see other property pages. Our first step will be to create a listener, actually 2 listeners, a listener on node 3 and a listener on node 4. The listeners will accept and service NVMe client requests, and we need 2 of them for both high availability and path failover. Next, we will create a namespace. We can think of a namespace as a LUN or a volume in the eye of the client. Ceph automatically wants to create 5 namespaces. We, on the other hand, will select 1 namespace at 32 gigabytes of a volume size. Our last step is to create an initiator record, 1 initiator record for 1 client. Of course, we could say a wildcard here. Any initiator can join, but that's not very secure. So we're going to paste in the NVMe qualified name of our initiator. Where did that come from? We'll show you later on the client side. So there's our client initiator, our 1 and only namespace at 32 gigabytes, our 2 listeners for path high availability. And circling back finally to the block group images, we see a Ceph RBD image that was created automatically when the NVMe property pages created our namespace. Let's swing over now to the client side of things. The first thing we will do is log in as a privileged user and then make sure that the NVMe over Fabrics CLI is installed. Step 2 will be to load the kernel module for NVMe over Fabrics. By the way, when you load the kernel module, that is an ephemeral load. It won't survive a reboot, but there are ways to make it persistent so that it will survive a reboot. Do you remember when we entered the host NVMe qualified name in the initiator property page in the Ceph cluster. Where did that come from? Well, it's an NVMe show host NQN. And here's a reprise over in the Ceph dashboard to show you where that property was entered that we copy pasted from our client. By the way, on the client side, there is a way to also set the NQN yourself rather than accepting the system generated default. Next, I will do an NVMe discover, selecting one of the nodes that's running our service and identifying the TCP port 8009, which is the Ceph discovery service for NVMe over Fabrics. Next is an NVMe connect, and again using my service node, but I do need to know the network qualified name of my Ceph listener service, and we'll see we're now mapped to a local raw storage device, and since we're connected to the NVMe over Fabric service, we have a mapping to a raw storage device on our local client. From here, it's standard file system operations, starting first with a makefs, then creating a mount point in /mnt, calling it NVMe demo, performing that mount of our local block device to /mnt/NVMe demo. Of course, we can validate that the mount succeeded with a df command. We can also inspect with df to see the capacity, which of course is 32 gigabytes. Now for some rudimentary file operations. We'll start out with navigation. From there, we'll create a couple of subdirectories, dir1, dir2. We'll do a touch, validating that we can write here the good old hello world by way of an echo. And finally, my personal favorites, let's do a DD of 10 megabytes from dev random, actually putting meaningful data into a binary file. For some reason, I like dev random because it's more than just zeros or a text file. It's just literally is binary data. It's very fast, pseudo device obviously, and there is our 10 megabyte file. From there we can do a tree. We can do ls commands, validating we have our files, and there is the 10 megabyte binary data file. Circling back one more time on our client, we can do a df to see that in fact we have started to consume capacity within our mount. You can take out a calculator and look at it for yourself against the 32 gigabyte volume on the NVMe service. Returning finally to our Ceph cluster, navigating down through the NVMe TCP property pages and expanding our subsystem group, we can look at performance details right there, context sensitive by way of Grafana. And this is where the Ceph developers and the community did it right. The metrics got into the dashboard properties on day one when the feature was generally available. And finally, this is why I created a separate pool for NVMe over Fabrics in the first place. Indeed, we can go to our Ceph pools and view context-sensitive or relevant overall performance, but there could be many pools. There could be additional RBD pools. Since we have an NVMe pool, we can go into performance details specific to my NVMe pool. So here we go, the last 7 days. This is when I put a significant amount of data in there, and we can see that spike of read-write activity. And with that, we conclude today's session of Ceph News at 10. This is John Schubeck posing the question, do you know where your data is? Take care.